Okay, today we're looking at the transformation of functions. We're going to review this topic. You should have seen this in grade 9 and 10 a little bit and have an idea of how to work with transformations of functions. So just as our review, we got this nice helpful review sheet for us here. So a vertical translation means we're going to add a number at the end and it will translate the function up or down by x units. Horizontal translation, h. So if we have a function of this format and we subtract h from x inside the bracket, then f is going to have a horizontal translation of h units. If h is positive, we go to the right. If h is negative, we go to the left. If we look at this example here, is h positive or negative? Why is h negative? Yes. So look at the format, it's always x minus, and the same as you get in a linear factor, it's x minus h. So if h is negative, we go to the left. If h is positive, we go to the right. If k is positive, we go up. If k is negative, we go down. Now, you're going to notice a shift in language used a little bit here for what we call vertical dilations. So we don't talk about stretch and compress. We talk about vertical dilation for both. So if the absolute value of A is larger than 1, we'll get a vertical dilation that will increase the size, like a stretch. If the absolute value of A is less than 1, it's between 0 and 1, basically, we'll get what you would see as a compress. We'll get a vertical dilation that will decrease the size. Same goes for horizontal dilations. That's going to be, the B is going to be inside the bracket. So if the absolute value of 1 over B will give you the dilation. So if we want to create a horizontal stretch, we're going to want to have a value of B, which is between 0 and 1. And this will create this. So basically, what we tend to remember is everything that happens inside the bracket is sort of backwards or reversed. And this helps us remember it. All right, so let's have a look at our first question. So let g be a function that is the transformation of the function f, such that g of x is given as 2f of x minus 3 plus 1. Describe the transformations of f that will result with the function g. Let's list them up in order that they happen as well. So list them up in order that they will happen. So take a minute or two, discuss with your partners, what are the transformations that we see here in this function?
First, you want to go for this and make the more operation. So it's a bracket that we force on to
What do you guys get? What did you get? That's okay. That's what the video is there. That's what the video is there. Catch as much as you can, but do try and have a go. Catch as much as you can, catch it up afterwards. Make sure you master it before the next lesson. All right, let's have a look at our answers here. So what's going to occur first? Number 1. No. No. Horizontal.
Yeah, horizontal.
Horizontal translation.
Because of operations.
Order of operations. Horizontal translation. How much? Left or right? Right. How much by? 3 units. What comes next? Vertical dilation. How much? We say factor 2. So vertical dilation factor 2. Number 3, we get vertical translation. Which direction? Up. How much? 1 unit. Okay, let's have a go at another example. Discussing your partners. 1 minute for this one. All right, let's have a look. What are we going to get first? Horizontal dilation. How much? What's the factor? Factor a half. This is going to be factor a half. Basically, it's going to be a horizontal compress. Horizontal compress. Because it's always the inverse inside the bracket. And if you look back to here, yeah, but you have a value that is between 0. If B is between 0 and 1, it will stretch it. Because if let's say it was a half, it's going to double it. Yeah. Okay, what comes next? We'll take that last, yeah? Vertical dilation. Factor 4. And then, what type of reflection? Reflection across the x-axis. How do we get a reflection across the y-axis? If B is negative. Yeah, the bit inside the bracket, if it's negative. All right, have a go at this problem. Copy down the sketch. Just pause the video here on this one. This might take you 2 or 3 minutes. All right, so with this one, we've got a horizontal translation. Is it left? And then down. Left 3 and down. So let's take the different points. This is at minus 3, 3. It's going to have to go back 3, so minus 6, and then down 3. So that's going, sorry, and then down 4. So minus 6, 1. This one's going to move to minus 6, minus 1. This point here is at 0, 1. So it's going to have to go 1, 2, 3, 1, 2, 3, 4. It's going to go down to here. This point here is at 3, 1. So it's going to go back to here and then 1, 2, 3, 4. It's going to go down to there. top of this is going to go back 1, 2, 3 to about the middle there, and then 1, 2, 3, 4. So the top of there is going to be about there, isn't it? And then this last point here is going to go back 1, 2, 3, and then down 1, 2, 3, 4. Let's make sure we give it the same sort of shapes. We've got a line here, a little bit of a semicircle there, and then a line here. Make sure your end points are the same. All right, have a go at this one. 3 minutes for this. Do this. Okay, so what we want to do for this one is start by identifying the key points that you're going to use. I'm going to use these points here. I'm not using the whole because it's on the line and I just have to go vertically from the other point here. Next up, I'm going to list the coordinates. So I've got -4, -3. I've got -2, 1, 0, -2. 4, -1, and then that last one is at 6, 4. So first I'm going to apply the reflection and the horizontal dilation. I'm just going to do these two first. So what are these going to do? The 2 inside the bracket is going to halve all my x values. The minus sign is just going to change the sign of my y values. So going through my list that I made, translating these ones, I need to halve these, so -2, and change the sign of y. So I need to halve each of these, change the sign of y. Halve this, you can't halve 0, you can change the sign of y. This is going to be 2, 1, and then this one is going to be 3, -4. Okay? So lastly, I'm going to do the vertical translation. So I'm just going to add 1. So I get -2, 4, -1, 0, 0, 3, 2, 2, and 3, -3. Then I'm going to plot my points. So I've got a -2, 4, so a -2 is there, 4 is up here. I'm going to start there. -2, 4. -1, 0. 0, 3. 2, 2. And 3, -3. 3, -3. So joining up my dots, it goes like this, goes like that, goes down like this, and lastly I have to add in my hole. It is there, so I need my hole there. There. Yeah? No, because after the transformations, the domain and range will change too. So the new function has a different domain. The original function had a domain. So if we just look at that, it's an interesting question because it's often the type of thing that we might ask. So the domain of the original function is -4 up to 4, and then 4 up to 6, like this. Whereas the new function is going to have a new domain. The domain gets transformed in exactly the same way. So this one is going to go from -2 up to 2, and then 2 up to 3. What's happened to the domain? Exactly. We have a horizontal dilation by factor 1/2 of everything in the domain. And you'll see the same with the range. So we have two things applying to the range. We have just the two vertical pieces. So we will see the range be reflected and then increased by 1. Often these type of things ask you to tell you what the new range and domain is going to be. So, all right, good question. In fact, there we go. Let's have a go at this one. Thank you for the segue. All right, 2 minutes for this one. Have a think through. Okay, so what we want to do for this one is let's identify the translations. So in that one, we've got a horizontal translation left by 3 units. So we've got left 3 units. So we can take -3. We can take -3 is less than or equal to x is less than or equal to 5. And this is going to be translated to -6 is less than or equal to x is less than or equal to 2. Let's look at the vertical ones. We've got a dilation. We've got a dilation of factor 2 and shift down 4. Let's do that. So we're going from 1 to 3. So if we dilate it, we're going to go to 2 to 6. And then if we shift it down, we're going to go -2 to 2. I'll just write it back in the form that they gave it to me. Like this. Okay, have a go at this question. 2 minutes for this one. Okay. So we want to find, let me do A first. We want to find, okay, sorry, just have to restart my Zoom. I ran out of time. All right, okay, there we go. So we need h of -1, which means we're going to need 3p of 2, -1, -1. That's going to give us 3p of -2. So then we can use the function given to find out what, if we put -2 into p, what we will get, and it is here. So we get 3 times 1 minus 1, which gives us 2. Let's try B. We need h of 2, so we're going to need 3p of 2 times 2, which is going to give us 3p of 4. This time we are looking at there. So that's going to give us 3 times 3 minus 1, 8, and so on. What did we get for the last one? Did we manage this one?
How did you get 1? It's like 3 times 1 1.
Okay, I'm with you. So what you're asking about is how did I get this 1 here? And it comes from this here. So if we put in -2 into the function p, it will map us onto the value 1.
So it's 1 times -2.
So So what we see here is that P of negative 2 is equal to 1. What we see here is P of 4 is equal to 3. And those bits occur. P of negative 2 is 1, P of 4 is 3. Let's do one more example, see if we can follow. Let's try the last one together, make sure we understand it. So we need 3 times P of 2 times 0. This one should be easier. So we've got 3 times P of 0. So P of 0 is this bit. So when we put 0 in there, we are going to get minus 1 out. So we get 3 times minus 1, which gives minus 3, minus 1 equals minus 4. Have I got this exam style question? 2 minutes for this. Okay, so if we look at the function that we've got a horizontal translation left by 3. So let's start there. We've got this as our domain. We have to take away 3 from each of those. So that's going to be minus 5, negative 1. So at this point, we're down to these two. Next, let's work out the range. So with the range, we're going to times by minus 2 and add 4. So we need times by minus 2 and add 4, times by minus 2 and add 4. That will give us minus 2 plus 4 is 2. Minus 2 times minus 5, it's minus 10, plus 4, minus 6. Now, because we've reflected it, they go the other way around, so we need minus 6, comma 2. Which one is that? It's here. All right, that's it for today. Have a go at the questions on transformations on the worksheet.